All right, hi everybody. This is question number 1 from week number 1 of this new version that we're calling school, from Monday's release of questions. So I am learning how to use this drawing tablet I got here. This is not going to be a great video, so just be prepared. But we are trying to find, we're trying to do related rate problems. Like we talked about when we were in class, it always came down to the first thing you gotta look for is, what do you ask? What do you ask to find? Find the rate at which the area is increasing. Okay, so we're talking about a rate that is your derivative. We're finding the change of the rate of the area. So dA is the change in the area. With these related rate problems, everything was done with respect to time. So that's what we're trying to figure out, is the change in the area. Now, we haven't thought about calculus in a while, more than likely. But if the derivative is increasing, that means it's going to be positive. So, something to think about. Now, in this question, the thing that we're dealing with is the area of a circle. So there's our formula that we're going to start with. Area of a circle, pi r squared. Again, my writing's even worse. I'm trying to use this new tablet thing here, and it's not great. But anyways, okay, when you take the derivative, so we got our equation. When you take the derivative, again, everything is done with respect to time. So the derivative of a is dA over dt equals, pi is a constant, so it just stays out in front, the derivative of r squared. I'm going to multiply the 2 out in front. Don't forget about the pi. R, that goes to the first power. But when we're doing these related rate problems, you've got to be thinking about that implicit differentiation idea and, more importantly, chain rule. So we multiplied that exponent of 2 out in front. We decrease that exponent by 1. So it just goes to r to the first power. But then we got to do the derivative of the inside. So we're thinking of r as some sort of function in terms of time. So we get dr over dt. There's our equation. There's our derivative. Now, up in the problem, it says when the radius of the outermost circle equals 10. So that's the radius. Remember, we're talking about a derivative. It's an instantaneous rate of change. When that radius is 10 meters, that's our instant. And then it says, and the radius is increasing at a rate of 2 meters per second. So that is our change in radius. That's what the dr over dt is talking about. It's increasing, so it's positive at 2 meters per second. We take these numbers. Once we take our derivative, plug it in. So we got 2. Pi. R is 10. I'm going to put parentheses around this, not a big deal. And the dr over dt is the change in radius. That is 2. 2 times 10 is 20, times another 2 is 40, times pi. Now, this is to get the units of our answer, we go and focus in on this. It's a change in area. Area is always a unit squared. Our units of length were meters, so this will be meters squared per the change in time. In our rate, we were talking about per second. So it's meters squared per second. There's our answer. That's how you do these problems, how you do this one specifically. Hope this helps.